When it comes to software, just making it work isn't the whole story. It also has to be strong. So today, we're not just going to talk about coding. We're going to learn how to think like a hacker so we can build software that's secure from the very first line of code. And this isn't about some boring checklist. It's about a whole new mindset. It all starts with something you probably do a dozen times a day without even thinking about it. You grab your phone, you open an app. A screen pops up. It seems so simple, right? Almost effortless. But that simplicity, it's really just an illusion. So, what do you see? A nice, clean interface, a spot for your username, your password, and that big login button. It's all designed to be super simple and get you on your way. For a typical user, that's pretty much the end of the story. But an attacker, they see something completely different. They're not looking at this screen to use it. They're looking at it to break it. To them, a button isn't just a shortcut. It's a potential door. A form isn't a convenience. It's a lock waiting to be picked. And it's this exact shift in perspective that is the absolute key to secure coding. And that brings us to the world that's hidden just behind that simple screen. Application security. This is where we start to understand that every single line of code we write either builds a stronger wall or it leaves a window wide open for an intruder. So what exactly is application security, or AppSec, as it's often called? It's not about the network firewall or anything like that. It's about the code itself. It really boils down to asking three critical questions. How does our software handle user input? How does it protect the data it stores? And how does it control who gets access to what? Think of it this way. You wouldn't build a whole house and then try to figure out how to bolt on a giant vault door, right? No way. Security has to be in the blueprint from the very beginning. And that's the core idea of secure by design, building software that is safe from its very foundation, not just patched up later on. Okay, so where do we even begin with all this? Well, the very first step is to see our application through an attacker's eyes and identify every single potential point of vulnerability. This whole process is called mapping the attack surface. The attack surface is literally every single place a user or even another system can interact with your application. Just think about it for a second. Every input field, every button, every API call, each and every one is a potential entry point for an attacker. Let's make this a little more concrete. Of course, login forms are a huge part of it, but so is the file upload feature. That's a massive potential entry point. What about APIs that connect to other services? Absolutely. Even a simple search box can be a vulnerability if it's not built to handle some, let's say, unexpected input. So why does mapping this surface matter so much? Because these aren't just features, they're gateways. They're what stand between an attacker and really sensitive data like personal info and passwords. And they're also what control access, making sure a regular user can't suddenly get the keys to the entire kingdom, right? So once you've mapped out that surface, the next step is the most important one of all. You have to fundamentally change your mindset. You have to stop thinking like the person who's building the house and start thinking like the person who's trying to break in. This one simple question unlocks the entire security mindset. Where could something go wrong? As a developer, you're trained to ask, does this work? But to be secure, you have to constantly ask yourself, how can I make this fail? It's a total shift from optimistic building to a healthy, strategic kind of paranoia. We can actually turn this mindset into practical questions for every feature we build. For example, what if I enter a line of code instead of a username? What happens if I change the user ID number in the URL? Can I suddenly see someone else's profile? And what if an error message gives away way too much information? These are the exact questions an attacker asks themselves. Theory is good, but let's make this really practical. We're going to take one of the most common features on the entire web, a simple login form, and we're going to put on our attacker hat. A normal user has one key, and they try it in the lock. Simple. An attacker, though, they show up with a whole bucket of keys, weird code snippets, and all sorts of strange symbols. They're not following the rules. They're here to stress test the system's assumptions, just looking for that one little crack. Let's start with that unexpected input. Instead of a normal username, what if an attacker enters a little snippet of database code? Now, if the form isn't built to validate its input, it might just execute that code. And that could potentially give the attacker access without even needing a password. This is a classic injection attack. Next up, there's the brute force method. An attacker can write a super simple script to try thousands of common passwords in just a few seconds. If there's no system to limit those login attempts, like say locking an account after 5 failed tries, it's really only a matter of time before they get in. Now, this one's a little more subtle, but it's so critical. If an error message says password incorrect, what has it just done? It has confirmed to the attacker that the username exists. A secure system, on the other hand, gives a generic response, like invalid username or password, offering up 0 free clues. So how do we organize all of these threats in a systematic way? Well, we can use a simple tool called an application surface card. It's a really straightforward way to document your security analysis for every single feature, and it helps turn that paranoia into an actual plan. The process is super simple. First, you identify the interaction point. For us, that's the login form. Second, you list the specific data it handles. Third, wearing that attacker hat, you brainstorm all the potential threats: injection, brute force, information leaks. And finally, and this is the key part, you turn those threats into specific questions the development team absolutely must answer. And here's what that card looks like for our login form example. See? It organizes our entire thought process. It takes all the abstract threats we just identified and connects them to concrete, answerable security questions. Is our input validated? Are login attempts limited? Are our error messages generic? The simple card becomes our blueprint for defense. And that's where we'll end it. Look, the point wasn't just to break a login form, it was to change how you see every single feature you build from now on. Because by learning to think like an attacker, you become a far better defender. The only question left is, what will you protect next?